Today we are going to be talking about adding and subtracting fractions. We'll be using our fraction circles and our fraction tiles. Okay? We'll also be looking at the PowerPoint. When we add or subtract fractions that are unlike, they're Chapter 22B, page 96, and our standard is adding, subtracting, multiplying and dividing integers, fractions, and terminating decimals, and performing exponential operations, including solving problems in everyday context. Now, we're going to look at several parts of today's lesson. When we have unlike fractions, it means that the denominator of the fraction is the last name or family group and tells the size of the pieces. The more pieces the whole is broken into, the smaller the pieces are going to be. For example, if you have the same size pizza, but they are divided into different amounts of slices, then you could have a box of pizza that was split into halves, 2 slices. You could have a second box of pizza, same size pizza, that's broken into thirds, into 3 slices. You could have the same size pizza in a different box broken into fourths, and the pizza is broken into 4 slices. If you have another box of pizza that's broken into tenths, then it has 10 equal slices. And if you have a pizza that's broken into 30ths, then the pizza, the same size as all the others, is broken into 30 slices. Now, we showed that by using our fraction tiles. Here is a whole, just like the Hershey bar that we used last week. I can take that whole, and if I have the same size, but I break it into 2 equal parts, then I have halves. 2 halves make a whole. I can take that whole, and I can split it into 3 equal parts. And now I have thirds. 3 thirds are the same as 1 whole. Okay? I can do the same thing with fourths. 4 equal slices, okay, put together are the same size as my whole. You can see I can do the same with fifths, with sixths, with eighths. I could do the same with sevenths, but our tiles do not afford that. I could do the same with tenths, 10 equal slices, or I can do the same with twelfths, 12 equal slices. Okay? My circles work the same way. I have a whole circle. If I divide the whole circle into halves, you'll see this. If I divide it into thirds, you'll see 3 equal parts. If I divide it into fourths, you'll see 4 equal parts. If I divide it into fifths, I can divide it into sixths. I can divide it into sevenths, however I don't have that tile. Eighths, tenths, and twelfths are nice and even, so these are the ones that we're provided with. Working with unlike fractions, you can see that because fractions with different denominators mean different size pieces, we cannot add or subtract until we have the same size pieces. For instance, if Sam eats a fourth of the pizza and Farron eats a sixth of the pizza, Sam's slice, the 1 out of 4, is much larger than Farron's. So they did not eat 2 slices out of, well, I don't know, because the value I can put in for the denominator doesn't make sense because the 2 sizes of the pizza were different. 1/4 and 1/6 are different slices. They are not equal in size, so I can't just add them together. Instead, I need the same denominator, the same size pieces. Now, when I go back to using my models, I can use the number line, but it's extremely tricky to do so because I divide the number line into parts between the whole numbers. Then I go back and divide it again using the other parts from the second denominator. If none of the lines match, there's no way I can look at this problem using a number line. I have to stop and find another method. If at least some of the lines match, then I have to make sure that there are truly equal pieces, that I did a good job dividing the number line, and I might be able to use the number line. For example, 1/4 take away 3/8. Well, I divided the number line into parts between the whole numbers with the fourths. So you see the little red, or actually they're much larger, red lines, okay? Here, here, and here. That makes 4 equal parts. All right. Then I divide it again with the second denominator, which are eighths. So I have these smaller green lines to divide it into 8 parts. 1, 2, 3, 4, 5, 6, 7, 8. And on this side, 1, 2, 3, 4, 5, 6, 7, 8. Okay? Now, since the 1/4 is also on a line for the eighths, I can proceed. I start at the 1/4 and I subtract 3/8, which means I move to the left, and I have to take the eighths pieces. 1 piece, 2 piece, 3 pieces. I end up at -1/8. Now, I can also use the fraction tiles. They help me see the size of the pieces, even if I'm talking about unlike fractions. I must line up the edges. When I add, I put the pieces together. When I subtract, I see how much is different. For example, 1/2 of a fraction tile plus 2/4 of a fraction tile equal a whole, because when I put 1/2 with edges lined up with the 2/4, then I get a whole. What that looks like is I have a half of a fraction tile, and I have a 2/4 of a fraction tile. When I put those together, okay, you can see that they are the same as one whole. Okay. 1 whole, 2/4 plus 1/2 equals 1 whole. Now, if I'm going to use another example, maybe I want to add 1/3 and 1/2. Now, when I try to compare them to see what that is equivalent to, the whole doesn't work. I have some extra hanging over the edge. So I go back and I try to find something that makes sense. If I use 6, I see that it works. 1/2 and 1/3 is the same as 5/6. Okay? But this takes a lot of trial and error to find when I'm adding 2 unlike denominators to unlike fractions and trying to figure out what my solution is. There's a much easier way, which I'm going to show you in the next section. In Chapter 22C, page 98, we are now going to add and subtract unlike fractions. Our same standard is to add, subtract, multiply, and divide integers, fractions, and terminating decimals, and perform exponential operations, including solving problems in everyday context. Now, in this example, or in this part of our lesson, we have unlike fractions. The denominators are different. They are different families or different size pieces. I must make the denominators the same size pieces or families before I can add or subtract. For example, I have 2/3 take away 5/6. If I don't use the number line, which is the hardest thing to do, or I don't use fraction tiles, which also can be time consuming with a lot of trial and error, and we're limited to what fraction tiles we have available, or we have to make our own, then we find the LCD. LCD again stands for least common denominator, or some people say lowest common denominator. I take my 2 unlike denominators and I find common factors. Because finding factors is just dividing my denominators, I can set up a double division problem. 3 and 6 can both be divided by 3. 3 divided by 3 is 1, and 6 divided by 3 is 2. 1 and 2 share no common factors other than 1, which is a waste of time. So 3 times 1 times 2 is my LCD, which gives me 6. Both fractions LCD need to be 6. To make that happen, I know, going back to my LCD factors, that 3 times 2 gives me 6. So I need to multiply 2/3 by 2 over 2. Then 5/6 doesn't need to change because it's already 6 as the common denominator. So 2/3 times 2 over 2 is 4 over 6. Take away 5 over 6. 4/6 plus the opposite of 5/6 leaves me with negative 1/6. Once you have like denominators, you can use tiles, number line, or logical thinking to solve your numerator. Your denominator, since they're both common and they're now like denominators, stays the same like denominator. Now, let's look at a fraction tile that does the same thing. I first start with 2/3, and I need to subtract, in that case, it was I needed to subtract 5/6. So we have 2/3, and I need to subtract 5/6. Here's 5/6. 2/3 take away 5/6. I line up the fraction tiles on top of each other, end to end, and see what is left over. Now it looks like 2/3 is equivalent to 4/6, and we found out when we did LCD that that was true. So what is left over is 1/6. But because I'm subtracting this amount, I don't actually have a 1/6 there to subtract. So then what I need to do is this would be a negative left over, negative 1/6. Because I started with 2/3 and I have to subtract 5/6. I can only cancel out what is the same, 2/3 and 4/6. What is left over is negative because we were subtracting or adding the opposite. Okay? Let's look at a couple of other examples. In the first example, you have negative 4/5 plus 1/12. 5 and 12, which are our denominators, do not share anything in common. So my LCD is 5 times 12, which is 60. Negative 4/5 must be multiplied by 12 over 12, and 1/12 must be multiplied by 5 over 5. Negative 4/5 times 12 over 12 is negative 48 over 60. And 1/12 multiplied by 5/5 is 5 over 60. Negative 48 plus 5, what they cancel out, 5 positives subtract 5 negatives, so I'm left with negative 43 over 60. 43 and 60 have no common factor, so I can't reduce it any further. In my second example, I have 5/6 minus 4/9. 6 and 9 share common factor of 3. So when I do my double division problem, 6 divided by 3 is 2, and 9 divided by 3 is 3. So my LCD is 3 times 2 times 3, which equals 18. 5/6 must be multiplied by 3 over 3, because 6 times 3 gives me the 18, which is the common factor, or common denominator. 4/9 must be multiplied by 2 over 2, because 9 times 2 gives me the common denominator of 18. 5/6 times 3 over 3 is 15 over 18, minus 4/9 times 2 over 2. 4/9 times 2 over 2 is 8/18. So my common denominator is 18. That means my answer's denominator is also going to be 18. 15 take away 8, I can rewrite as adding the opposite. 15 plus negative 8 is going to be a positive 7/18 because I have more positives than I have negative. Now on my third example, I have negative 2 over 25. Take away negative 11 over 15. My two denominators are 25 and 15, so a common factor they share is 5. 25 divided by 5 is 5, and 15 divided by 5 is 3. My LCD then is 5 times 5 times 3, which gives me a common denominator of 75. Negative 2 over 25 must be multiplied by 3 over 3. And negative 11 over 15 must be multiplied by 5 over 5. So negative 2 over 25 times 3 over 3 is negative 6 over 75. When I am subtracting a negative, I change it to adding the opposite. The opposite of negative is positive, so I'm adding 11 over 15 times 5 over 5, which is 55 over 75. Negative 6 over 75 plus 5 over 75 equals negative 49 over 75. That is incorrect. That should be a positive 49 over 75. I will make sure I change that. There are no common factors between 49 and 75, so I can't reduce any further. In the final example, we have negative 11 over 18 plus negative 11 over 12. 18 and 12 share a common factor of 3, which reduces to 6 and 4. 6 and 4 share a common factor of 2, which reduces to 3 and 2. My LCD then is 3 times 2 times 3 times 2, which gives us 36. Now negative 11 over 18 times 2 over 2 plus negative 11 over 12 times 3 over 3. Negative 22 over 36 plus negative 33 over 36 equals negative 55 over 36. Since I have an improper fraction, in order to reduce, my solution will be negative 1 whole and 19 over 36. So please feel free to use our fraction tiles to add or subtract unlike fractions to get a feel for it, or to demonstrate it on your paper drawing the fraction tiles that work for you. Or you may use the fraction circles. A little bit more difficult to look at, but if you are thinking the round, then please feel free to do that. You also have number line if you feel up to the challenge. It is very tricky. And you also have LCD logical thinking. Okay, thank you.